Hello to everyone. Dear students, I hope you are fine. Today we will start the lecture regarding canonical forms or normal forms for linear second order partial differential equations. So I welcome you all in the lecture series of partial differential equations, and today we are going to formally start the methodologies which are required to solve second order partial differential equations. Canonical form is not a method, actually it reduces our partial differential equation into some more suitable or convenient form so that we can easily solve our partial differential equation. So you remember that in the last lecture we had in the previous lecture we have studied the introductory discussion regarding second order partial differential equation, general form for second order partial differential equation, and linear second order partial differential equation. We also had studied the material regarding parabolic, elliptic and hyperbolic partial differential equations, and from there we will continue our study and we will try to transform the partial differential equation into some convenient form which is known as canonical form or simplest form. It is also known as normal form. But there are two questions which always come into the mind, that how you will do that. I mean, how you will convert your partial differential equation into the canonical form. Number two is what is the benefit of transforming your equation into that simplest form or natural form. So I will give you the answers later, but let's begin that how we will proceed further. We know that a, b, c, d, e, f, g are continuous functions, and their partial derivatives are also continuous, but they can be reduced to a canonical form or a normal form or a simplest form. There are many names for that. Natural form is also used for canonical forms. The transformed equation assumes the simplest form so that the subsequent analysis of solving equation will become easier. So this is our main target. Firstly, that in order to solve or study the partial differential equation, we are actually transforming the equation into more convenient or easiest form. That form is known as canonical form. But since we are transforming the equation into simplest form, so there will be some methodology, and that is known as mathematical transformation. So what we are doing, actually we know that our dependent variable is u, and this dependent variable which depends upon xy is now dependent upon some new variables xi and eta, and we are actually what we are doing, we are transforming our desired equation into some new equation. So previously it was u of xy, but now after the transformation this will become u of xi eta. Okay, xi eta. Okay, so this will be the main target, and that linkage or that methodology will be called a transformation, which is revertible. Okay, transformation. Okay, now the basic question which arises in someone's mind, that what will be this transformation? Okay, this xi and eta. So generally xi and eta will be what? These will be functions of x and y, xi and eta. Okay, okay, and in order to have canonical form, this transformation must be determined. Okay, in order to have the canonical form, this transformation must be determined. So what will this transformation actually do with your PD? This transformation reduces our partial differential equation into a simpler form, and therefore this transformation is required in order to proceed further. But how we will calculate, in just a moment I will tell you the answer. But remember that you are having a transformation for xi and eta. The definition of Jacobian is given as this: J is the Jacobian, which is analytically given by partial xi over partial x, partial xi over partial y, partial eta over partial x, and partial eta over partial y matrix with determinant. So this determinant quantity is known as Jacobian, and this should not be equal to 0 at any point, okay, in the domain. What is your domain? Your domain is x comma y, because xi and eta are dependent upon x comma y. So no matter which domain you are taking, in that particular domain Jacobian must never be 0, because if it is 0, the transformation will not be revertible, and it will not be feasible for us to do the calculations. We are taking the transformations which are revertible, and we are bound to have Jacobian which should be non-zero. Okay, this is the assumption which we will use, that for any transformation, regardless what are xi, what are eta, the main condition which should be fulfilled is that Jacobian must never be equal to 0, okay, in the prescribed domain. Now since this is a new transformation, new variables, so your partial differential equation will be changed or transformed into some new equivalent form. So what will be that form? We will calculate, but this is a partial derivative with respect to x 2 times, and all other partial derivatives should be calculated now in the new form, because we are having the transformation xi and eta. Ux will be changed. How it can be changed? Using the chain rule. If you use the chain rule, this partial derivative will become uxi xix plus u eta eta x, okay. Uy similarly becomes uxi xiy plus u eta eta y, and similarly uxx will become uxi xi x square plus 2u xi eta xix eta x plus u eta 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 x square plus u xi xi xx plus u eta eta xx, and similarly other partial derivatives. The important scenario is for uxy, because uxx can be calculated from uxy. Ux and uy are very easy, because this is the simplest chain rule. For uxy, I will try to show you the calculation so that you understand the calculations regarding uxx and uyy as well. So let's start the calculation for uxy. Okay, uxy. What is the answer for uxy by definition? So every time try to apply the definition for any simplest calculation. This will be equal to partial over partial x of uy, okay, uy. And now what is uy? You know by chain rule that uy is this quantity, okay, uxi xiy plus u eta eta y. So you should put that quantity, okay, uxi xi xiy plus u eta u eta eta y. Okay, so this was the chain rule for uy, and you are having partial derivative with respect to x as well. But look, this partial derivative will now actually be distributed with respect to chain rule using the transformation xi and eta. You are trying to calculate partial derivative with respect to x, but x is a new variable. So what you will do, you will do like that. Okay, firstly we should distribute the partial derivative, okay, for both terms which are in the summation form, this plus this, okay, because it will now make easier for us to focus on the calculation. And now uxy will be equal to, in the next step uxy will be equal to, now apply the chain rule. Okay, there is a product u xi xi y and u eta eta y. So how you will do that? What is actually partial over partial x in the chain rule? So partial over partial x will be what? As an operator, I am taking as an operator, this will be equal to partial over partial xi, partial over partial xi, and partial xi over partial x, partial xi over partial x. Okay, but this will be added by one more quantity, which is partial eta, partial over partial eta. Okay, this same with respect to eta, eta x, because eta is also function of x and x is also dependent upon eta. Vice versa you can do, because we are supposing a revertible transformation. So this quantity will be replaced here, this operator actually, not a quantity, replaced here, and we'll try to calculate the product rule. Okay, so now how you can proceed further? You can calculate this quantity as like that. Yeah, partial, okay, firstly apply the chain the product rule, because there is a chance that we can make mistake. So if we apply the product rule, what will be the answer? The answer will be okay, apply the product rule. So the answer will be something like that: first function derivative of second, okay, plus second derivative of first, which means this, and derivative of first. Okay, similar to that you should apply the chain rule here similarly, but with respect to y, sorry, with respect to eta. Okay, u eta eta y eta, and also here eta. Okay, when you now apply the product rule, now we shall apply the chain rule as well now, because partial over partial x is given by that distributed chain. So if we apply this, what we will get? We will get that uxi, okay, here partial over partial, instead of partial over partial xi we will get partial over partial x, we will get partial over partial xi, partial xi over partial x, partial xi over partial y. So I am putting first term, okay, we will get partial over partial xi, okay, partial xi over partial x, partial xi over partial x, partial xi over partial y as well. Okay, I mean to say the similar thing with respect to y. So if okay, I should write up the term firstly. So again distribute this, let's make a bracket because uxi is common for all. Yes, now it's better. Now this is in two terms, okay, first term is this and the second term is with respect to eta as well. So when you apply with respect to eta as well, there will be a summation and the answer will be this with respect to xi y. Okay, this thing. Okay, this is the answer for first term. Okay, similarly for the second term you will get what, control B, you will get the answer for that term. Okay, this term is distributed with respect to this, so you can replace here. Okay, partial over partial xi, partial xi over partial x, and uxi. Okay, the second term will be what? The second term will be, I am writing now here, the second term will be the same thing but with respect to eta. But since xi y again is common, so we will shall use the bracket. Okay, so okay, let's put here the quantity this. Okay, so now here will be what, the second term but with respect to eta, and the function was initially uxi. Okay, so there should be uxi. Okay, now there will be some third and fourth term, but I am writing similarly because at the end of the calculation we shall just change xi with eta, there will be the similar answer. Okay, so this is with respect to eta and similar this was with respect to xi, so ultimately we can calculate the answer very easily. So in the next step what we will do for the first two terms, because third and fourth term shall be calculated very easily. So now this should be distributed. Okay, how this should be distributed? There is uxi, no problem. The answer for that term will be partial square xi over partial x partial y, and this is partial over partial xi. Okay, so the answer shall be, I think this should be cancelled by this, and the total answer will be the total answer shall be partial uxi. So we have on the left hand side, look, we have first term uxi xi. Okay, so the answer will be yes, the answer will be yes, xi x, xi y, and that should be with this. Okay, I think I have written in not a good form, but this should be linked with this. So the answer will be uxi xi double derivative with respect to this. Okay, uxi xi, yes, now it's better, uxi xi, okay, and eta xi x xi y, xi x xi y, xi y. Okay, very easy. Now for the second one, the quantity will be similar, but partial over partial xi eta. So you can write not u xi xi, you will write u xi eta. Okay, xi and eta, and the other quantity is eta x eta y. So you can write eta x and eta y. Okay, this quantity is done. It was better initially that I should write there, okay, because we are dealing with operators, and we should write operator on the left and quantity on the right. Okay, similar to that, we can calculate the answer for this. This answer should be what this answer will be. Okay, you know that now. This is xi y, so the answer should be partial over partial xi, and partial xi over partial x is xi x xi y, and this will be u xi xi. Okay, because xi x is there, this is a partial derivative, xi y is there, this is a partial derivative. The only derivative which you can take is u xi xi. So the total answer is u xi xi, means double derivative, and the second quantity is partial u xi over partial x, partial xi over partial y. So you can write partial xi over partial x and partial xi over partial y. But this is similar to this. Yes, I think I have a mistake. Okay, no, not like that, because yes, because we have a problem here. The problem is you cannot put like that. Instead you do one more thing. This is xi x and this is xi y. Okay, and I think I have made mistake for that term. Maybe this was u xi and xi x xi y, sorry, u xi x xi y is there. Okay, okay, I will explain you this thing in the next lecture. I think I am having a mistake here. Maybe I am not so careful. This will be partial xi over partial y, and this will be partial xi over partial there. Okay, so the answer is total this one, no problem there. Similar to that, we can calculate for eta as well. This is there is no problem. The problem is for that quantity, the middle term. This can be calculated like this is xi x and okay, yes, this is not there, and the answer is partial xi over partial x. So there is xi eta, no problem, but this is not 2 times because there will be some mistake. I think there was partial over partial x. For that it's okay, but for the other one we have okay, uxi, we are right, and the answer will become yes, xi xy, because this is xi x, this is xi y, but this will be u xi xi, which I don't want, and for that reason partial or partial x was replaced by partial or partial xi, partial xi or partial x, and we had initially as well partial xi or partial y. Okay, so the total answer will be partial xi xy. Yes, I'm sorry, initially this was cancelled. Okay, this is cancelled by this, okay, this quantity, and the answer will be partial okay, this is cancelled by this, so the answer will be partial square xi over partial x partial y. This can be written as partial x y. Okay, I'm sorry, this term was not there, and u xi is not there. The answer is only u xi. Okay, and the second term is very similar. The answer is, this is cancelled, so the answer is partial xi over partial y, and partial over partial x as well. So the answer is eta, sorry, not xi, eta x y. Okay, and you have u xi eta. Okay, look, you have u xi, no, not u xi eta, only xi. Okay, okay, now the second term is okay, no problem there for that. And for the third term, similar to that, we will have what? We will have plus, okay, sorry, fourth term, you have also fourth term, so the answer for that will be similar to that. Okay, we have u xi xi x xi y, so the answer will be u xi eta. Okay, you are having u xi eta, and u xi with respect to eta x and xi y. So you have eta x, okay, and xi y. Okay, this is your total answer. So this is the answer for 4 terms, one for that, second one for that, third one for that, and fourth one for that one. Plus there will be 4 terms from them also. How can you calculate? Similarly, just focus on the first term. First term was u xi x y. Okay, so their first term will be u eta x y. Okay, the same thing with respect to eta. Okay, same thing with respect to eta. Okay, same thing with respect to eta. Now for second term, it will be equal to u, this was u xi eta xy, so the total answer will be u eta, instead of xi you will have eta, okay, eta, and instead of eta you will have xi. Okay, for the third term, for that second quantity in the summation, you will have u eta eta x eta y. Instead of xi you will have eta you will have eta and eta x eta y. Okay, and for the last term you will have u xi eta instead of you will have eta xi. They are both equal because we are having continuous first order partial derivative, no problem for that. Instead of eta you will have xi, and instead of xi you will have eta. Okay, this is the total answer. You are having 1 2 3 4 5 6 7 and 8 terms. You 1 2 3 4 and there you have a summation. Okay, you are having the last term like that. Okay, yes, you are right. Now you can simplify more as well. How? This is equal to what? I have written in the standard form related to second order derivative. So you can start from there. U xi x, this is the first term, plus u xi eta, the second product, u xi eta is there, and u xi eta or eta xi, they are both similar, is there. So this is a common term, and in the middle you will have eta x xi y, eta x xi y plus xi x eta y. Okay, this is the middle term, and now the last term is for the other one, u eta x eta y. This is the last term, second last term, and one remaining term is the linear terms, u xi xy plus u eta xy. This is the arrangement which I have written. So I am concluding, there was second order partial derivative with respect to xy. What you have done, you have actually calculated it by definition. Uxy was partial over partial x into uy quantity in terms of xi eta was that, and you had distributed partial derivative. Now partial over partial x is in the chain rule, can be written as like that. Now uxy will be this with respect to that terms, there are two terms, so uxi will be there, partial over partial x of that, plus you are having actually product rule. So when you have applied product rule, uxi will be there, and instead of partial over partial x you can replace this, instead of partial over partial x you can replace this, and for that terms as well, but I am not putting that because analogously I can write the expression for that one, because the difference only is with respect to eta. In the first we have xi and in the second we have eta, look there. Okay, now what you can do, actually what we were having a mistake, I am sorry for that. What was the correct way? The correct way is that you must relate uxi, this is there, okay, this will be cancelled. You are having partial derivative of xi with respect to x and xi with respect to y, and also their partial derivative with respect to xi. So one xi should be cancelled and the other one will be partial square xi over partial xy. This is xi xy. In the second term you will have uxi, similarly this is cancelled for that, and partial square xi over partial xy, sorry, partial square eta over partial xy, you have that. And in the second term you can do that, uxi is there, and you have partial x xi x, this is xi y, and this is second derivative of partial u over partial xi, so you have second derivative. For the third term similarly, the this thing with respect to eta. So only change is with respect to eta. The answer is uxi xi by eta x. Uxi is there. Okay, you will get xi y is there, eta x is there, and you will have u xi eta. So you have a u xi eta. Similarly, interchanging xi and eta, you can write the other 4 terms, and after rearrangement we have u xy answer. So in general, what I was trying to tell you that you will calculate, this was actually I was trying that you should calculate, but no problem, you now know how to calculate the partial derivatives into new transformation. After you put the partial derivatives into the original equation 1, which is that your required linear second order partial derivative. So if you put there, you will get something like that, some constant a bar of u xi xi, some constant b bar of u xi eta, some constant c bar of u eta eta, equal to some new function which was, if you remember, the non-principal part, secondary part, you can name that capital F. And now if you put these values uxx, uxy, uyy, uxi, these expression into 1, you will get this equation 4. But what can be a bar, b bar, c bar? A bar will be equal to this, b bar will be equal to this, and c bar will be equal to this. And the new discriminant, the previous discriminant was b square minus 4ac, but new discriminant will be b bar square minus 4a bar c bar. Look, this bar notation is used for transformation. After the transformation, your equation becomes this. After the transformation, your coefficients become this, and after the transformation, your required discriminant becomes this. And now if your partial differential equation is hyperbolic, for that this will be positive. Okay, no problem. If this is positive, this is a square of some quantity, this will always be positive, or it can be 0. But can it be 0? This is actually this Jacobian. So this cannot be 0, this cannot be 0, and this square will always give you a positive term. So what I am saying to you that the new discriminant sign actually is dependent upon only one thing, which is the previous discriminant. This shows that the transformation of variable does not change the type of partial differential equation. If it is parabolic, hyperbolic, after the transformation it will remain hyperbolic, because after the transformation b bar minus 4a bar c bar will also be positive. Now it is a good step that you should understand and develop a theory that based upon this transformation, how can you calculate the canonical form for the case 1, case 2 and case 3. This will be done in the next lecture, but up till now just focus on these partial derivatives and try to have a practice of these partial derivatives, and try to, if you can, do calculations of uxx and xy, uyy with by your hand. It will be easier for you for the next coming questions. So in the next lecture we will try to study the cases for canonical forms. I mean to say, if a partial differential equation is hyperbolic, so with the new transformation how can you find a suitable form? Similarly for parabolic and elliptic. Thank you very much for listening.